Good afternoon, guys. I'm going to make a video presentation about zone allowance computations. So let's start, guys. I think I have already made a video about this in my previous videos. But anyway, this will be a review of sorts and a further explanation of the presentation. Okay. Hope you bear with me. Okay, let's start. So this is the problem, guys. The vessel MV Nara's next voyage is to load at Coquimbo. This is Chile for discharge at Longview, Washington, basis on loading calculations. So letter A, it says here, load port is Coquimbo, Chile, and the zone is tropical, and maximum draft at berth is 10 meters, density 1.05 meaning salt water, and B at discharge port at Longview, Oregon. So Longview, Oregon, load line zone is summer, and the maximum draft at berth is 40 feet. The density is salt water, freshwater 1.00, and bunkering Arobi departure of Coquimbo. So prior to departure at Coquimbo, the bunkers as follows: FO 375 metric tons, DO 35 metric tons, LO low oil is 15 metric tons, freshwater ballast constant Arobi. So these are the bunkers that going to receive at Coquimbo, Chile. And Arobi departure at Coquimbo freshwater is 150 metric tons, ballast is 0, and constant is 180. Okay, so where is this Coquimbo, Chile? So let's take a look, guys. Coquimbo, Chile is this one. This is the Coquimbo, Chile, and take note, guys, is at the open sea, so the vessel should be docked around here and dock around here. Okay, and where is it? Is somewhere around here, guys. So it's somewhere around here. Oh, I'm sorry. What happened? Let's put it this way. Chile is somewhere around here. So it's going to discharge at Longview. So you will go here, pass this way, and you will pass this 13th north latitude. See, from here, it's going to travel this way, going crossing this 13 latitude north, and proceed to Longview. Maybe around somewhere around here. So from here, Chile travels like this, going up, passing the 13th latitude north, and go up, and going to Longview around here. Okay, see where is Longview? Longview is Longview. You go inside Astoria, then go passing the channel, then going to Longview. And here is Portland, Vancouver. Longview is Oregon. So here. So we used to travel here before when we are in a log ship and we go to Portland. But here you go only to Longview, this one. And where is what's next? Longview. So from Chile, you go here. This will be your 13th latitude, 13 north latitude, somewhere around here. Passes this 13th latitude, then you go somewhere around here, Washington or the Longview. Sorry, Longview, Washington, somewhere around here. Okay, this will be the discharge port. Next will be, this is Vancouver. So it passes here, Los Angeles, passes San Francisco, the Oregon, and Washington. Somewhere around this is the, I think, going to Astoria around here, and there will be Longview from here. Okay, so let's go back to the problem. Uh, so consumption laden voyage, meaning laden voyage when you are loaded. Daily consumption is 25 metric tons per day. FO and DO diesel is 1 metric tons per day. Freshwater production is metric tons per day. Freshwater consumption is 12 metric tons per day. So you have more consumption than your production. Okay, now F distance speed. So yes, your laden speed is 40 knots. From Kimbo to Longview, from Chile to Longview is 5,604 nautical miles, and from Kimbo to 13 North is 3254 nautical miles. Meaning from Chile, from Coquimbo, Chile, passing to this north latitude, this line here will be, will be 3,254, okay, from Coquimbo to 13 North. Okay, so let's follow the problem. Says here the displacement at departure loading port. So what is the displacement at loading port? Meaning displacement at Kimbo, your departure displacement, the maximum amount of cargo to load, okay, and the maximum permissible sailing drop, or your sailing drop at loading port, and assume that the density is at load port is 1.009. Find the maximum permissible drop. So what will be the maximum drop if you are floating in a density 1.009? Okay, assuming that she is about to complete loading and floats at a drop of 9.34 meters on backwater density of 1.009. Find how much more cargo she can load. Okay, meaning how many remaining cargo are going to load. That is what it meant here. Now the solution says here. Number one, identify the different zones of the voyage. Meaning, stated here, you're a tropical zone in Chile, okay, at load port. At Longview is summer zone. Okay, so tropical zone in Chile, you are a summer zone in Longview, Oregon. Okay, back to the number two. So identify the governing zone. So this is the governing zone. Different zones. Governing zone is tropical and summer. Okay. Calculate the total non-cargo weight to be deducted from the dead weight. Okay. Calculate the non-cargo weights. This is how you do, guys. So put down the ROVs let's say FO is 735 here because already put bunker. DO is 35 here, and your LO is 15. Your LO here 15, and your ballast is 0. Ballast is nil, and your constant is 180. Constant is 180. I advise that you make this table like this, so it will be easy to compute. So here you have your ROB, your weight or departure ROB, then your consumptions per day, steaming time, consumptions, total consumptions, ROB, arrival at port or arrival at discharge port. Okay, so we have already put here the weight of the ROB, consumptions per day. So here consumption says consumptions on a loaded vessel or laden voyage, FO is 25 metric tons per day. So we have here 25 consumption per day. DO is 1 metric tons per day. Put here 1. And your freshwater is 6 tons per day consumption. So your production here 6 times consumption. Okay. Now your steaming time is 9.7 days. So we're speaking about from Tukimbo to 30 north of 354 metric tons. Okay, from Coquimbo, Chile to 30 north. From this figure, from Coquimbo, Chile, going to this borderline of 30 north, that will be 3252, okay? And let's say, how did I get this 9.7? Okay, I go to the, where did I go? Okay, this one. So, take note guys, the Coquimbo to Longview is 5604 nautical miles. Which is this one guys. And Coquimbo to latitude 13 is 3254 nautical miles, which is this one guys. Coquimbo to 13 north latitude is 3254 nautical miles. Okay. Now, we just concentrate on this Coquimbo to latitude 30 north, okay? So the distance is 3254 and your laden speed is 40 knots. So 3254 divided by 4, that will be your steaming time is 232.4285 hours, okay? So this number of hours divided by 24, that will be 96.6845 days. So round it up, that will be 9.7 days. That's how you get this figure, okay? Since you already steaming time of 9.7 days, 9.7. So this consumption of fuel oil multiply it with your steaming time, you will get 242.5. That will be your total consumption for the entire voyage from Coquimbo to 13 north latitude, okay? And DO, you have a consumption of 1 metric tons per day multiplied by 9.7, then you get 9.7. And your fresh water, you got 6 tons consumption per day times 9.7, then you have 58.2 metric tons consumption, okay? And your total ROB will be 3104. And your arrival at Longview will be this one, okay? This total minus this one, then you get this one. Total minus this one, I mean 9.7 minus 35, then you get this one. Then you maintain the LO. And 58.2 minus 150, then you get 91.8. You get zero ballast. Constant is the same 180, and your ROB arrival along view is 084.6. Okay, that will be this one, guys, by manual computation. Then you get a total ROB departure 1115, and your total consumption is 310.4, and ROB is 04.6, which is this one, guys. Okay, so you get here 1115. Okay, 1115. Then you get here 310.4. Get your 310.4, your total consumption, and your ROB is 804.6. 804.6. Okay. Now, governing zone. Let's stick to this one, guys. First, says here, number 1, find the displacement at departure at loading port. So what will be your displacement at loading port at Coquimbo, Chile? Departure displacement. Okay. Let's go to the problem. So the summer zone at your summer zone at the governing zone at Longview is summer zone. Okay, summer zone, summer. So from give you an idea, if this is Chile and this is Longview, the governing zone here is tropical, and the governing zone of Longview is summer. So what you do, this total consumption, you add this consumption to the displacement of your summer, so that when you arrive here, you will maintain this displacement of departure in an arrival in Longview. Okay, so that will you arrive in Longview of summer draft or summer displacement. So what you do, this total consumption, you add it to your summer displacement in Longview, so that when you reach Chile, you totally consume this 310.4 metric tons. Then your displacement will be the same of 30884, which is the summer. Okay, when you arrive in Longview. Okay, so from here, you consume 314. Then when you arrive at Longview, this will be your displacement summer zone. Okay, so you add what will be the summer zone, what will be the summer drop of what is the summer drop of what is the drop of summer zone, summer winter or same winter zone. So we go to the program. I'm sorry. Okay, so let's go to the capacity table. This is look for summer and its displacement should be 30884. Okay, take note of the summer displacement is 30884. So summer displacement is 30884. You add the total consumption for the entire voyage of 3310. When you add that, it will be your departure at Chile. Okay, 31194. This will be your departure displacement. Okay, this will be the answer. The displacement at departure at loading port. So this will be your displacement. This, I'm sorry. This will be your summer displacement of displacement will be 31194. What will is the drop of this one? 31194. We go to the program. You go to the static. Then you put 31194. That's correct. Double check. 31194. Okay. 31194. You press enter. And the corresponding drop will be 63638 9.638. 9.638. I got 6. You got put here 637. And what will be your, that is the summer salt water, because using the drop, using this is saltwater drop, because using this interpolation of the hydrostatic, this is all computed by through saltwater. So this will be your saltwater drop of 9.637. I guess 638. What will be his brackish water of 1.009? So what will be his drop when the ship is floating at 1.009? He got 9.778. Okay, so this is his solution. Look up of this is his formula. The displacement of salt water of 91194 multiplied by salt water 1.025 over 1.009 of brackish water, and your lookup density of 1.009 is 31689, and its corresponding drop will be 9.778. Okay, so by using this formula, you will get the corresponding displacement of 1.009, and his brackish water drop will be 9.778. So this will be his departure drop of this will be his departure drop this will be his departure drop I think this will be his brackish water of 1.009. Okay, departure, yeah, this will be his departure drop, okay, of 9.779. I have made I have made a program by Excel. Excuse me, where is it here? So here the displacement was 31194. Yeah, here 31194, multiply it by 1.025, multiply 1.025 over your dark water of 1.09, which is same with this one. Okay, so 31194 multiplied by 1.025 over 1.009, that will be the brackish displacement will be 31689. So I got here. So displacement of 31194 times your fresh water 1. Or salt water 1.025 over 1.09, and your the water displacement is 31688.65 or 31689, which is this one, 31689. Okay, and the corresponding drop will be 9.778. 9.78. Okay, 9.778. So we check the program. That will be 31689. Okay, 31689. 31869. Is that correct? 31869. We'll enter 31689. 31689. 31689. That will be 7. That will be 778. 31689. 31689. 31869. 31689. 31689. 31689. Ay, ando. 31689. 316. 31689. Okay. There. 31689. 9778. We got 9.778. Okay. So with this formula, guys, I made. So you just, it's the same. You put the displacement, multiply by your salt water or density 1.0225, divide your local density of 1.009. You apply the formula, and you will get the displacement of 31689. 31689, you put your 31689, then you get 9.778, which is this one, guys. Okay, that will be your departure. That will be the maximum. That will be the maximum sailing drop of 9.79. Maximum amount of cargo to load. Okay, number 2. Maximum amount of cargo to load is this one. So from your departure displacement of 31194 minus your light ship, which is 6772. Light ship. Light ship. Light ship is 6772. Okay, your light ship is 6772. Minus light ship equals your dead weight of 24422 minus your deductible weights, which is this one. Sorry. Okay, or this one. Deductible weights of 11115. Then your maximum cargo to load is 23,307. So that is this one, maximum cargo to load. Okay. This will be your maximum cargo to load. Okay, number 4. Assuming that the density of load port is 1.009, find the maximum permissible drop or the ceiling drop. Assuming that this is load port is so this will be your maximum ceiling drop, guys. This will be your maximum ceiling drop, guys, of 9.778, because this is your maximum departure drop in salt water, which is 31194, which is 637. Because you're floating in a density of 1.009, your drop at brackish water will be 9.778. This will be your maximum ceiling drop of 9.778. So this will be your maximum drop of 9.778. Assuming that she is about to complete loading floats at 9.34 on top water density of 1.609. How much more cargo can she load? Okay. I will just follow this one, guys. This is your target drop, this is your present drop, this is your sinkage, okay? This is, I will first disregard this one, guys. I will use my program. So I will go there to here to my form 6. Okay, form 6 is how to fine trim when handling several moderate weights. Okay, so the problem says, assuming that it's about to complete loading and floats at a drop of 9.34 on dock water density of 1.09. Okay, so she floats at 9.34. Forward drop will be 9.34. Up drop is 9.34. So that will be your main drop. This will be his LCF, MTC, MTPC example, and your mid drop port. Actual mid drop port is 9.34. And stopper mid drop will be 9.34. So your actual mid drop is 9.34. So at this stage, guys, when you are reading a drop, this will be together with you, a chief officer, and the drop surveyor. So when they go around the vessel and check the drop, assuming that the drop forward is 9.34 and the drop up is 9.34, the actual mid port is 9.34 and the actual mid starboard is 9.34. So the mid port is 9.34, okay? And your departure drop is this one, guys. Your departure drop should be 9.778, okay? Or 9.78, okay? So your departure drop is 9.78, 9.78, okay? Take note, guys, when you take this drop of your initial drop of 9.34, the density here is 1.009, and that when you in your sailing drop should also be the density of 1.009. So the same, guys, the final drop here, the density is 1.009, and your initial drop is the density is 1.009, okay? Now look here, the TPC of this departure drop of 9.78, there's an interpolation here of your TPC which is 35.63, which is this one, okay? Okay, so what is the remaining your sinkage is 44 centimeters. How? Your final mid drop minus your mid drop is your 44 centimeters, or 9.34 from this drop of 9.34. It will take, you have to sink 44 centimeters to reach 9.78. Okay, I repeat, your patient drop is 9.34 mid, so you have to sink 44 centimeters to reach 9.78 of your departure mid drop. Okay, so to get the sinkage, you just, your final mid drop minus your mid drop is your 44 centimeters. Now, with this sinkage of 44 centimeters, you convert this to metric tons. So what is the formula? The formula is here, K8, which is your sinkage, K in 8, sinkage times 100 constant times M3, which is M3, which is the TPC, M3. So, meaning your recommended cargo to load for trimming is, the formula is your sinkage times 100 times your TPC of 3563, and your value would be 15675. Okay, that is recommended cargo to load for trimming. That is what you meant here. How much more cargo can she load? How much more cargo can she load? Meaning, what will be your trimming load or trimming cargo to load? Okay, to reach 9.77. Okay, that's what she meant there. Okay, so when you get this value of 15675, scroll down, follow the arrow, and you put the value of 151567.5 for the sake of computation. Okay, press enter. Once you already, what will be the result if you put 1567.5? Your exact value for mid drop is 78 exactly, and 44 here. What if you put, let's say, 1568? 1568. So we put a 1568. So there's a little bit more here. Okay. I just put for the sake of, okay, for the sake of, because we don't use points in loading, just round it up to 1568. Okay. So change here. Then go to trim holes 2. You go to trim holes 2. Then your cargo to load is 1568. Okay. Here 1568. Assuming that your trimming holes is 1 and 4. Put 1 and 4. Okay. And scroll down. Say you have 0 trim. You don't have any trim. Then what will be your cargo to load in number 1? So number 1, you're going to load 653. You put 653 here. 653. And number 4 will be 915. 915, number 4. And what will be your departure drop? Departure drop will be 9.78. 9.78 up, forward. Your trim 0 and mean is 9.78. And your deflection is 0. Okay? This is for your mean. And how did you get this mid? This is the one. 78013. This will be 78013. This one, 78013 here. So 780. That will be your mid here, this one. Okay, then we go to form number 6, and you load number 1 of 653, put here, and number 4 is 915 here, and the ceiling drop will be forward is 9.78, up is 9.78, your trim is 0, and your main is 9.7801. So mid is 9.7801, which is this one, and your main is 9.7801, which is this one, and your deflection is 0. Okay, so look guys, 9.78, your departure drop is should be 9.778 or 78. Okay, just round it up like this. Okay, then look at the trim table. Your initial drop is 9.34.
Spanish.
Four and up.
Spanish settings lang daw yung Spanish settings.
Up drop is 9.34. Mean is 9.34. This is your mid departure. Even killed, and this will be your final departure drop, 9.78 forward. Up is 9.78. Main is 9.78. Mid is 9.78. Your departure mid, so your 0 trim. And this will be your trimming load. Remaining cargo to load is remaining cargo to load is 1568, which is this one. I'm sorry, 1568. 1568. 1568. This one, 1568. Okay, so that is your trimming 1568. Then number 1, you load 653. Number 4 is 915. This will be your correction of hold number 1. Forward correction and up is up correction. Number 4, your forward correction is this one, and your up correction is 6.8. But this, take note guys, I want you to see this one. This is for capesize vessel. Okay, so what I did, I just input this forward correction so that I can come up with this drop of 9.78 up, forward and up, and main of 9.7. So I just made this forward and up correction for holds 1 and 4. So from this one, your final departure drop is even keel of 9.78, 0 trim. Okay, and this one is another solution of trimming table. Okay, first you have to load in hold number 4. The cargo to load would be 915. Okay, when you load 915, this will be the forward correction. Number 4 will be same here, and up will be the same here. After loading 915 in hold number 4, from your initial drop of 9.34 forward and up, this will be your final drop after loading 9.15. Forward will be 9.18, up will be 9.96. Then you have to load in hold number 1. So how much cargo you're going to load in hold number 1? 653. Then number 1 should be 653. Number 1, you have the same correction. 9.1. 9.1 here. Up will be 2.8, negative 2.8. Okay. So after you loading 653, your final drop forward will be 9.78. Your up drop will be 9.78. You have 0 trim, and your main will be 9.78. Okay. And you will have a deflection of 0. Okay? So this is actually what you call the trimming two holes. Okay? But let's go to the problem. Here, take note, there's two methods of finding the amount of cargo to load of 1521, here 1529. Okay, the first method is by TPC. First, you have to get a sink gauge. So the sink gauge will be 0.44. So from your target drop of 9 point, this will be your departure drop of brackish water, 1.009, and your present drop of 9.34 of brackish water, 1.009. The difference between the two will be 44 centimeters, which is this one, guys. 44 centimeters. Okay. So you got 44 centimeters of sinkage. Then TPC of 3476. How do you get this 3476? So salt water of, you get a salt water of 3531 multiplied by 1.09 over 1.025. Then you want TPC, corrected TPC of 3476 of, that will be your brackish water TPC of 3476. Where did they get this 3531? Okay, let's check, guys. It says here 39340. 39340, 9.34. TP should be 3530. 3530. It should be 3530. Okay? 3530. You got 3531. Multiply it your 1.09 brackish water over. You follow this formula, then you will get this TPC brackish water of 3476. So what happens is we apply this 3476. Okay? 3476. Take note, guys, this TPC of from this drop of 9.34 of 3531. I got here 3530. Okay. Small difference. Okay, just follow this one. So this will be the brackish water corrected TPC in brackish water of 3476. So we apply this 3476. So 3476, 34.76. Then your recommended cargo total is 1529. Okay, 1529. Here, 1529. Okay. So what happens here? 1529. We'll just proceed with this. So you get 1529. Scroll down. Then you put 1529. 1529. Okay. That will be. Look, guys, it's not exactly. It's not the same with this your final departure made of this 1.001. Okay, it's almost the same. Then we go to trim two holes. Then your 1529 trimming hole is 1 and 4. You have 0 trim. And your how much you're going to load in hole number 1 should be 637. Put 637. 637. Number 4 should be 892. 892, and your final drop will be, departure drop is 9.78. 9.78 for run and up, trim 0, and main drop is 9.78. 0 deflection. And your number 1, you load 637. Number 4, 892. Then your departure drop is forward and up is 9.78, the same, trim 0, main drop, you have a 0 deflection. Okay, take note, guys. Take note. Okay, take note. Let's go back. Okay. Just put here 1579, 1529. Okay. Then with this density, RTPC corrected density, but if I will use this correct TPC, which is equals, then put enter, that will be 1567. That will be 1567, 1567. Okay. What is the difference? Minus difference of 38 tons, guys. Okay. So for me, you take note, if I will use this actual TPC of this drop, I will have more 38 tons with the same drop. With the same drop. Okay. Okay, I will put here. Here. 1567. 1568. Over here. 1568, number 653. 653. 653. 915. You got the 915. There you get, okay. And here you get the same. Okay. Here you get the same. Okay. 97978. Then you go. Look, guys. Here I got the same draft. 978, 978. But I still have an excess cargo of 38 tons, guys. Okay. So I don't have to use, meaning I don't have to use this formula of taking the exact value of TPC to duct water of 1.09, but I still got the same drop of 9 value. I have an excess value cargo of 38 tons with the same departure drop of 9.7878. So I would rather use this exact TPC, because the final mid of 978, by interpolation of TPC, this is the exact value of your TPC of 3563. Okay. Now going back to the problem, so I would not recommend using this one. Okay. And this is another solution. Say 9.34. Yeah, you get the density, the displacement. Okay. This is salt water. So what is the displacement of 3944? 30144. 30144. 31194. What will be 29 29673. 29673. Just check, guys. Very day. Displacement method 9.34. Convert that to 1.009 to salt water. Okay. 3144. Okay, 314 degree. Three one four four. 311,994. Ah, 3134. Okay, 3134. 3134. Okay, 3134. 934. Displacement. 934. Displacement is 934 displacement. Salt water is 30144. 30144. Okay, 30144. You convert to local density. 30144. Okay, 30144. Okay. 30144. 30144. That what will be, this will be 30144 or 9.34. 9.34. What will be his salt water? That be 29673. 29673. Got here guys, 29673. Minus your salt water displacement or departure displacement of 3114. Your displacement will be 1529. 1521. Okay, so how did I get this one? So with 34 0.34, your displacement salt water is 30144. 30144. I put 30144. This is your present drop. You have the duct water 1.009. What will be, this is duct water. What will be his displacement and salt water? Displacement and salt water will be 29673, which is this one guys. 29673. Okay, you deduct it from your sailing drop or sailing displacement, which is this one, 31194. Then it will be your remaining cargo to load. But I would recommend this one guys. Okay, you have your present drop here 9.34. Your mid drop 9.34. So your mid drop is 9.34. Your final mid departure drop is 9.78. Okay, so you have a sinkage of 44 centimeters, and your interpolated TPC of 9.78 is 3563, and your recommended cargo to load for trimming is 1567. Then you put it here 1568, run it up. What happens? Then you have drop, mid drop of 9.780, the same, and 44 the same. You go to your trimming two hoods. Your trimming cargo to load is trimming cargo is 1568. The trimming hole is 1 and 4. You got zero trim, and to load in hole number 1 is 653. 653. Number 4 is 915. And your forward drop will be 9.78, up drop is 9.78. 03 main is 9.78, and you have a zero deflection. Okay, so that's it, guys. I hope you like this video. If you like, please click the like button, share, and subscribe. And don't forget to click the notification bell. Thanks for watching. Hey guys, I want to take note that this 310 310 uh, metric tons. This is from Chile to 13 north latitude, because from here this will be your summer drop. So from Chile, from here, this will be your tropical zone, boundary of your tropical zone. This, and when you reach here, it will be summer drop, summer zone, okay? So it's only 310 metric tons is computed from Chile to this border of. Okay, thank you, thank you. Oh, okay. So from Chile to your borderline of 13 north latitude. Because this is tropical, when you reach this, when you pass this one, it will be summers. It's only through this boundary. That's why your computation is only 310, which is this one, guys. So you can put steaming with this distance of 3252 divided by 14. Steaming time is 332, and your steaming days is only 9.7 days, which is only up to this Kimbo Coquimbo to latitude 30 north. Okay, I hope you that would be the good explanation. And so that's why you only compute up to this north 30 north latitude. Okay, I hope that's clear. That's an additional info. I hope you're not confused. So thank you very much again for watching. Goodbye.